Hello, this is Mrs. Ward, and I am going to go over the classwork for section 7.7, which is the determinant of a square matrix. And we've already talked about it as a determinant because we did the determinant to find the inverse. So when we go to do number 5, that you already know how to do. We're just going to do the first part of the inverse formula. So I'm going to take 6 times 3 and get 18 minus, and then 5 times 2, and that's going to be negative 10. When I add, I'm going to get a determinant of 28, and that's it. That's all I have to do. Now, in the book, it'll ask you to find the determinant, and sometimes it'll say using cofactors and minors. We are not doing it that way. We are just going to do the loops. So remember, you copy down the first 2 columns just the way I see them. So I'm copying down the 1, negative 4, 5, the 0, negative 1, and 1. And then I highlight. And I'm going in the same pattern that I went here. So I'm going down from the left to the right, like a negative slope. And I'm going to do these first. So when I do that, I get negative 5 plus 0 plus 0 minus. Now I'm going to do my loops the other way. And so that'll be 0, that'll be 0, and that'll be 0. So they're all 0. That makes life easy. So 0 plus 0 plus 0. So I end up with negative 5 minus 0, which is just negative 5. So what you're doing when you're finding the determinant is you're putting a number value on that array of numbers. So number 13 and 14, just want you to do this in your calculator. Just testing to see if you know how to do that. So we're going to get out our calculators. I'm just going to start a new document, and I'm going to add a calculator page, and then I'm going to type this in. So what I'm going to do is I'm going to hit Menu, Matrix, and Vectors, and then number 3 says Determinant. I'm going to choose that. It gives me the parenthesis, and that's waiting for me to add a matrix in there. So I am going to push the button between the 9 and the catalog, going to the 3 by 3. The matrix they give me is a 3 by 3, so I'm going to leave those 2 values the same. And now I'm going to type in what I see, which is a 0.1, 0.2, 0.3, negative 0.3, 0.2, trying not to make a mistake. And when I do that again, negative 0.22. And give me a second. I want to bring that over, so I'm going to pause you guys. So I brought that over, and there's my answers in negative 0.022. Numbers 19 and 24, this is where the book is telling you to find the determinant by expanding, and it gives you a row and a column, row 1 and column 2. We're not following those directions. There's a whole other way to find determinants that we're not going to go over. We're just going to do the loops. The loops work for 3 by 3s. They do not work for 4 by 4s. So we're just going to stick with the 2 by 2s and the 3 by 3s. So here this is what I'm going to do first. So when I do that, I'm going to have negative 15 plus 24 plus negative 12 minus, doing the loops the other way, I'm going to have 10 plus 54 plus 8. And so when I add these two, negative 27, so this will be negative 3 minus, and this will be a negative 72. No, it'll be positive 72, so I'm going to subtract and get a negative 75. So that's the answer for that one. 24, doing the same thing. Again, the book will tell you about rows and columns. You're ignoring those directions. You're doing the loops. So you're copying down the first 2 rows, and then you're doing your loops. Remember, you always do, like I think of a negative slope, but however you want to think about it. Love it when I have zeros in there. And so when I do that, I'm going to have negative 66 plus 0 plus 0 minus, and then we're going to do the loops the other direction. Oh, look at that. They all have zeros. So that'll be 0 plus 0 plus 0. So I'm going to end up with negative 66. And I would probably take the time to check both of those on my calculator. Number 33 is a 4 by 4. Remember, I said the loops do not work, so we're not going to do the loops. We are going to put this in my calculator. So I'm going to do the first steps I did before: menu, matrix vector. Number 3 is determinant, pushing the one that I get to change the dimensions. And this matrix C happens to be a 4 by 4. So I'm going to change those dimensions to 4 by 4. Hit OK, typing in those numbers exactly the way I see them without making a mistake. I hit enter and I get negative 336, which is the correct answer. And I'm just going to bring that over and put it on the page. Okay, the next one. The next one wants me to find the determinant of A, the determinant of B, then it wants me to multiply the two matrices, and then it wants me to find the determinant of the product. So the first thing I'm going to do is I'm going to find the determinant of A. And remember, those two lines that look like an absolute value, that's what they mean. That means determinant. So this will be negative 3 minus 0, which is negative 3. So the determinant of A is negative 3. The determinant of B is going to be negative 2 minus 0, which is negative 2. Now it wants me, for part C, it wants me to find the product between these two, and I like to write them down next to each other. Now it doesn't tell me that I have to do it by hand, but I'm going to practice doing it by hand. So I'm going to have negative 1 times 2 plus 0 times 0 and get negative 2. Then I'm going to have row 1, column 2, which will be negative 1 times 0 plus 0 times negative 1 and get 0. Row 2, column 1 is going to be 0 times 2 plus 3 times 0, and that will be 0. And row 2, column 2 will be 0 times 0 plus 3 times negative 1, which will be negative 3. So A is going to be negative 2, 0, 0, negative 3. Then to find the determinant of AB, I'm going to do negative 2 times negative 3 and get 6, minus 0 times 0 and get 0, and I get a determinant of 6. And the whole reason why they had you do that is if I go up here and I take negative 3, which was the determinant of A, and I take negative 2, which was the determinant of B, and I multiply those two, I will get the 6. So what it's saying is that the determinant, you do the determinant of two individual matrices and then multiply the determinants, or you can multiply the two matrices and do the determinant of the product. Either way, you're going to get the same answer. And that happens all the time, so that was fun to do. Number 46, they want us to verify, so I'm just trying to show that it'll work for every single one that I have. So remember, these two lines that look like absolute value mean determinant. So if I were to multiply these, I would have W times C times X. I just sort of went in the order that I saw the letters from left to right. Minus, doing the same thing, this will be C WX, and I'm trying to show that that's equal to 0. Well, remember, the order that I multiply in does not matter, so I can rearrange this one to CWX, because I can, they're all represented there, and minus CWX. So if I take the same thing and subtract itself, I'm going to get 0 is equal to 0. So I've shown that, or I verified that equation. The next one, I want to find the value of X so that the determinant is equal to 20. So I'm just going to go ahead and do this, and I'm going to do X times X and get X squared minus negative 1 times 4 and get negative 4, and I'm trying to show that that's equal to 20. So this is x squared plus 4 is equal to 20. Subtract 4 from both sides. I'm going to get x squared is equal to 16. Square root, and x is equal to plus or minus 4. And if I wanted to check it, I could put in 4. I could do 4, 4, negative 1, 4, and see if I get 20. Or I could do 4, actually it's negative 4, 4, negative 1, negative 4, and see if I get 20. And I do. This is 16 minus a negative 4, and that does equal 20. So it does check. And it checks for this one as well. Moving on to the next one, 52. I am going to solve for x knowing that the determinant is equal to 8. So 9x times x will be 9x squared minus 4 times 2, which will be 8, is equal to 8. I'm adding 8 to both sides, and I'm going to get 9x squared is equal to 16. Divide both sides by 9, because before I can take the square root, I should have it isolated on one side by itself. I'm going to get x squared is equal to 16 over 9. Then I'm going to take the square root, so square root, square root, square root, square root, because I'm taking the square root of both the numerator and the denominator. And I'm going to get x is equal to plus or minus 4/3. And again, if I wanted to check it, I would put that back up here and for the x. Okay, let's do number 57. So 57, same thing. I'm going to take the determinant. So I am going to do 2x times the quantity of x minus 1. I'm going to take my time to do that. Minus 1 times negative 1, which will be minus the negative 1, is equal to x. Distributing this 2x, I'm going to get 2x squared minus 2x plus 1 is equal to x. Well, it's quadratic, so I'm going to bring this x over here, and I'm going to have 2x squared minus 3x plus 1 is equal to 0. My product is 2, my sum is negative 3, so I'm going to do my product sum, and it's going to factor as 2x minus 1 times x minus 1 is equal to 0. When I solve this, I'm going to get x is equal to positive 1/2. Here, x is equal to 1. And then I could put those back in and check. 60, same thing, it's a 3 by 3. So before I even start, I am going to take my time to write those, copy down those 2 columns. So I'm just going to copy down the whole thing. X, 3, 2. Copying down the first 2 columns. And then I want to set this equal to 0. So I am going to multiply, whoopsie, wrong thing. This, this, and this. So when I do that, I get negative 6, and that's going to be plus 0, minus 4. And then I have minus, doing the loops the other way. And I'm going to have 0 plus 6 minus 2x, and this is all equal to 0. So I'm going to have negative 10 minus, well, I can make this minus 6 plus 2x is equal to 0. So I'm going to have negative 16 plus 2x is equal to 0. Add 16 to both sides. And then divide both sides by 2, and I get x is equal to 8. And then a quick way to check this is just put 8 in this spot here, put it in your calculator, and see if you get a determinant of 0. And the last question is just a simple true or false question. It's saying if a square matrix has an entire row of zeros, so let's do a 2 by 2, an entire row of zeros, the determinant will always be 0. Well, you know, since I'm proving it, let's just put in variables instead of 3 and 4. So that way I'm showing it's true for any number. So let's say I have x and y. So if I do this and I'm trying to find the determinant, I would do 0y minus 0x, which would be 0 minus 0. So that's going to be 0. If I did a 3 by 3, let's expand that to a 3 by 3, an entire row of zeros. Then let's do A, B, C, E, F, G. Now to do the determinant, I would copy down the first two rows again. So let me copy down 0, A, E, and then 0, B, F. When I go to do the loops, this will be a 0, this will be a 0, and this will be a 0. And then I'm going to subtract, oh, another 0, another 0, another 0. So this statement up here is going to be true. If you have an entire row of zeros, or an entire column as a matter of fact, you're always going to get a determinant of 0. All right, I hope this helps, and we will see you next time.